Heart tissue engineering. Heart tissue engineering is a complex and challenging process that requires a multidisciplinary approach, involving experts in cell biology, materials science, and biomedical engineering. The adult heart is a vital and highly specialized organ of the human body, with limited capability of self-repair and regeneration in case of injury or disease. Engineering biomimetic cardiac tissue to regenerate the heart has been an ambition in the field of tissue engineering, tracing back to the 1990s. Increased understanding of human stem cell biology and advances in process engineering have provided an unlimited source of cells, particularly cardiomyocytes, for the development of functional cardiac muscle, even though pluripotent stem cell-derived cardiomyocytes poorly resemble those of the adult heart. In the past decades, tremendous advances have been witnessed in the field of tissue engineering, TE, especially concerning stem cell engineering, the development of functional biomaterials and biomimetic scaffolds, and the implementation of biofabrication tools for the generation of complex biological structures. The process of heart tissue engineering consists of various steps. 1. Cell isolation and culture. The first step is to isolate the cells that will be used to create the engineered tissue. These cells are usually obtained from the patient's own heart tissue or from a donor's heart. The cells are then cultured in the laboratory to increase their numbers. 2. Scaffold preparation. A scaffold is a structure that provides a framework for the cells to grow. In heart tissue engineering, scaffolds can be made from a variety of materials, such as collagen or synthetic polymers. The scaffold must be designed to mimic the mechanical properties of natural heart tissue. 3. Seeding of cells onto scaffold. Once the scaffold is prepared, the cultured cells are seeded onto it. The cells must be distributed evenly throughout the scaffold to ensure that the tissue grows uniformly. 4. Cell differentiation. After the cells are seeded onto the scaffold, they begin to differentiate into the various types of cells that make up heart tissue, such as cardiomyocytes, endothelial cells, and smooth muscle cells. This process is typically induced by adding specific growth factors and other biochemical cues to the culture medium. 5. Maturation. As the cells differentiate, they begin to form functional heart tissue. This process can take several weeks or months, during which the tissue is maintained in a specialized bioreactor that provides the necessary environmental conditions, such as oxygen and nutrient supply. 6. Implantation. Once the tissue has matured, it can be implanted into the patient's heart to replace damaged or diseased tissue. The success of the implantation depends on factors such as the compatibility of the engineered tissue with the patient's immune system, and the ability of the tissue to integrate with the surrounding tissue. Thanks for watching.